Right, today in geometry we are looking at our last section, 6.6, triangle proportionality theorems. Right? So let's go through these. The very first one, the triangle proportionality theorem, says if a line is parallel to one side of a triangle, intersects the other two sides, then it divides the two sides proportionally. So in this picture, we have triangle ABC and triangle XBY. It says if line A is parallel to line XY, then, okay, so the two sides that it intersects, it divides those two sides proportionally. So the first side that it intersects would be BX, so then I could say BX over that same one, XA, would equal the other side, BY, over YC. Okay. So that's what the triangle proportionality theorem tells me. Then we have all of these different options, okay? So we have this picture, okay? We have the top is labeled A, the bottom side is B, the entire side is G. Over the other side, the entire length is H, the top is C, the bottom is D, and then in the middle, we have labeled E and F. So using that triangle proportionality theorem, we're going to fill in the missing part of each proportion as it would apply to this figure, okay? So if I have A over B, so A proportional to B is going to equal C proportional to, well, D. Right? So this is going to be a D. So now I'm going to switch colors here. A proportional to G, so the top half proportional to the entire length over here is equal to C proportional to, I would need that entire length over here, H. Right? Switch colors again. So now I have E proportional to F, so I have the parallel, right, in the middle. So E proportional to F is going to equal A proportional to, well, this side, C. The next one, again, if E is proportional to F, but this time what over H? So over that whole side, well, what would this whole side be on this one? G. And a last one, they have A over E, so A over E would be the same as G over F, right? That bottom. E and F always have to go together in that picture, right? All right, so those are lots of different ways that we could write those proportions, right? So using all of those that we just talked about, now we're going to work out some examples. So it says find the length of X. Okay, I need to set up a proportion. Okay, so I can do this side over this side. Right? Would have to be proportional to this one over this one. That's what the triangle proportionality theorem tells me. So I would set this up 28 over, 28 over X would have to equal 30.8 over 16.5. So there's our proportion. Now we just want to cross multiply. So 30.8x equals 28 times 16.5. We're going to go ahead and multiply out 28 times 16.5 and get 462. Divide by 30.8 to get our x all by itself. So then I get x is equal to 15. That's all that they asked me to do was find x, so this x is 15. We can talk about common sense. Okay, does my answer make sense? Okay, I see that this side is 28, this one's 30.8. This one was bigger, so that would mean that this one would have to be bigger than this. This was 16.5, I got 15. That's smaller, makes sense. Okay, so we can always kind of double check ourselves that way as well. All right, next page. We're going to look at the converse of the triangle proportionality theorem. Remember, converse is where we trade places with the if-then. So here it tells me if a line divides the two sides of a triangle proportionally, then it's parallel to the third side. So here they start out telling me that BX is proportional to XA, and that's equal to BY proportional to YC. Then I would know that AC, so segment AC would be parallel to segment XY. So if I start out knowing the proportionality, then I automatically know that the lines are parallel. All right, we're going to look at another proof. So this proof, given CB is proportional to BA, which equals CD proportional to DE, they want me to prove that BD is parallel to AE. So we always start out with our given. So my very first statement, CB over BA equals CD over DE, given. All right, so I need to be able to prove that those lines are parallel. If I could prove that my triangles were similar, then I could prove that those lines were parallel. So let's first see if I can prove that these triangles are similar to one another. Okay? So in order to prove that they're similar, I would need to get CB, so I would need to get CA over CB equal to CE over CD. So that's what I would need to get. Right? So CA, how can I get CA in my statement? Remember when we first talked about proportions and we learned all of those properties? Okay, I know that I can take CB over BA and say that's the same thing as CB plus BA over BA. What I do that side, I have to do this side, so this would be the same thing, CD plus DE over DE. My reason, this was the add numerator and denominator property of proportions. So remember we had those 4 rules of the proportions, those 4 properties, so there's one of them. So now I have CB plus BA. Well, what is CB plus BA? CB plus BA that whole thing is CA, but I can't put that in there yet because I don't have a CA in here. So I need to now say CA equals CB plus BA, and then the same thing over here. EC equals CD plus DE. And that's SAP, segment addition postulate. Right? So now CB plus BA, I can substitute that with CA. So I'm going to rewrite that CA over BA. CD plus DE I can replace with EC over DE. I replaced, so that's my substitution. Now I have what I said that I needed over here. So now I've got my sides are proportional. I can get that angle up there, right? Angle C congruent to angle C by the reflexive property of congruence. So now I can say that these triangles are similar. So I can say triangle, let's see, CAE is similar to triangle CBD by the SAS similarity theorem. If I know that the triangles are similar, then I know all of the other parts, right? Then I know that this angle is congruent to this angle, this one is congruent to this one. So now I could say angle B congruent to angle A, angle D congruent to angle E, by the definition of similar triangles. So now I have corresponding angles that are congruent. Corresponding angles prove parallel lines. So now I can say that segment BD is parallel to segment AE. Remember, if I'm proving lines parallel, it's always the converse. So converse corresponding angle postulate. Okay. All right, so that's another one of our proofs. So let's go on and look at some more working out problems. So now we're going to look at the two transversal proportionality corollary. Okay, so this tells me that if three or more parallel lines intersect two transversals, then they divide the transversals proportionally. So here I have line AB parallel to line XY, parallel to line JK. Then I could say that those are proportional, okay? So then I can say that all the way down, AJ is proportional to over here, So all the way down, AJ is going to be proportional to the small part, XJ, would have to equal on the other side, all the way down, okay? EY over YK. I am so sorry, I completely wrote this wrong. We're going to go back. We're going to do the little part, AX would have to be proportional to EY. That would equal XJ proportional to YK. There we go. Right? All right, so if we want to find the length of X, right? So I've got, and they're going to tell me that these three are parallel. Okay, so if I know that these three lines are parallel, right, I can say that this one is proportional to this one. So X over 18.4 is going to equal proportional 21 over 24. Cross multiply, 24 times X equals 21 times 18.4. 24X equals 386.4. Divide by 24, X equals 16.1. I'm going to ask myself, does that make sense? This number was bigger, okay, than this number, so that means that this number would have to be smaller. 16.1 is in fact smaller than 18.4. All right, then we have our triangle angle bisector theorem. It tells me if a ray bisects an angle of a triangle, it divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. Right? So here I have my ray. It's bisected this angle. Okay? Angle B got bisected, which means cuts in half. So it divides the opposite side, so my opposite side is AC, into lengths that are proportional to the lengths of the other two sides. So if angle ABX is congruent to angle XBC, then I could say this opposite side, so AX, is proportional to AB, which would equal CX proportional to CB. So let's do an example of that. So here, find the length of X. I see that this has been cut in half. So I could say 12.5 over 15 would equal X over 21.6. Cross multiply, 15X equals 12.5 times 21.6. 15X equals 270. Divide by 15, X equals 18. Does that make sense? Okay. This was the bigger one, so this would have to be bigger than this, right? 18 is bigger than 12.5, so that makes sense. All right, so the very back, now we have to decide which proportions that we're using to set up, right? It's not the example right after the theorem that we looked at. So find the value of x for each of the following. So number one, I see that I have an angle that has been bisected. So I know that I'm using my angle bisector theorem. So I could set up and do this side over this. So x minus 4 over x would be equal to 9 over 12. I'm going to cross multiply. So 12 times x minus 4 equals 9x. I need to distribute, so I get 12x minus 48 equals 9x. We get all of my x's on the same side. I'm going to move my 12x over, so then I would get negative 48. 9 minus 12 is going to give me negative 3x. Divide, so negative 48 divided by negative 3, x is equal to positive 16. Number 2, I see that I've got parallel lines, right? So this is our triangle proportionality theorem. So I could set up that side over this. So I could say 4x over 25 is equal to 24 over 6x. Cross multiply, 4x times 6x equals 25 times 24. 4x times 6x gets me 24x squared equals 600. Divide by 24, x squared equals 25. I don't want x squared, so take the square root of both sides. Since I'm looking at length, I only need the positive one, x equals positive 5. Number 3, I've got the 3 parallel lines with my transversals in here. So I could say this one over this, so 16 over 18 would equal 3x plus 11 over 36. Cross multiply, 3x plus 11 times 18 equals 16 times 36. So 3x times 18 is going to get me 54x. 11 times 18 gives me plus 198. 16 times 36, 576. I'll get x by itself, so subtract 198, so I get 54x equals 378. Divide by 54, x equals 7. All right, last example for the day. Again, I have parallel lines. I have the 4x and the 20, the 2 and the 8. So I could say 2 over 4x is equal to 8 over 20. Cross multiply, 8 times 4x equals 2 times 20. 8 times 4x, 32x. Equals, oh, I am so sorry. I made another mistake on that one. Let me erase. Oh, erase. I did not set that up properly. Go back. So remember this 2 over 4x, okay? So 2 over 4x equals, over this entire bottom is this entire side up here. So it's 8 plus 2 over 20. So really 8 plus 2 is 10. So I have 4x times 10 equals 2 times 20. I forgot to do that entire side length. So 4x times 10 gets me 40x. 2 times 20, 40. So x is equal to 1. All right, so that concludes section 6.6. Your homework is going to be a worksheet 6.6. Again, I'm not giving you any proofs for homework, okay? You can study them up in the notes, okay? But the homework is all just going to be applying the theorems to find missing values. Tomorrow we will go over the test review together, and then Thursday take our Chapter 6 test.